Hello, welcome to this tutorial. Today I will explain how to build a trunk between a Mikrotik router running RouterOS and a Cisco switch running iOS. This is my first recording, so I would like to ask you to leave a comment below the video to let me know how you think I did, and if you would like to see more of these tutorials. Having said that, let's get into it. Our agenda of today. We will first go into what is a VLAN, what is a trunk, and when and why do we need a trunk. For many of you, this can be already known. And if that's the case, I will leave a timestamp in the video description that you can click on and you can skip the theory and get right into the configuration. If you would like a refresher, or if this is new, then yeah, stick with me and I will go into that. After discussing what a VLAN and a trunk is, we will go into a presentation on the GUI, where we will configure a VLAN, a trunk, and connect ports to the VLAN through Winbox. We will do the same in the CLI. And as a bonus, I will show you how to configure VLANs and trunks on a Cisco. After the presentation, I will give a live demonstration because I believe that it will sink in even better when you see it live than just watching a presentation. And since this is a recording, I will leave you my contact details for questions. You cannot ask them as you put in a live stream. So yeah, I will leave you my contact details and feel free to reach out with any questions or suggestions you might have. And at the end of this tutorial, we will know what is a VLAN, what is a trunk, and how to configure them on both Mikrotik and Cisco. So what is a VLAN? If we take a new switch out of the box and we do nothing to it, all the ports are usually in the same broadcast domain, which is a logical part of a network in which all the connected nodes can see each other and communicate with each other. And that has pros and cons. One of the big pros is, of course, that it's really simple to just plug everything into the switch and it can communicate. But there might be cons when you look at it from a security perspective. Maybe we have systems that should only be maintained by specific departments. Maybe a finance department has their own server that they have full access to, but they would not like the rest of the company to have full access to it as well. So from a security perspective, it makes sense to divide that switch into multiple logical switches, if you will. Another thing to take into consideration is that we can all hear each other's broadcasts when we're all in one broadcast domain. And if you think of a large room with many people in it, if somebody speaks very loudly all of a sudden, everybody is distracted. Now it could be that he or she is speaking loudly because they have an announcement that's meant for you, so you have to pay attention. But it could also be that they're talking to somebody else who is a bit further away or who was just not listening. So they raise their voice. And if you broadcast like that in a large room, it's a distraction for everybody in the room. Because you do need to listen in to determine, is this meant for me or can I safely disregard it? And the same goes for nodes on a network. If there's broadcasts on a network, everybody has to listen to it to determine, is it meant for me? Should I do something with it or can I safely disregard it? If it's such a distraction, you may wonder, what is the use case of broadcasts on a network? Well, there's several use cases. One of them is, for instance, DHCP, where a node doesn't have an IP address, a gateway, doesn't know about the DNS servers, and it wants to learn all those details from a DHCP server. It will try to discover a DHCP server by doing a broadcast. Yeah, as I said, broadcasts are a distraction, so we want to limit that. And we don't want them to get out of hand if we have many hundreds or thousands of computers connected to a single broadcast domain. So that's another reason to cut up our switch into logical broadcast domains. And these logical broadcast domains, that's what a VLAN is. So as you can see in the picture here, we have a switch with two VLANs. We have the red VLAN 10, we have the green VLAN 20. And the result of cutting up the switch like this is that A and B can talk to each other and C and D can talk to each other, but A and B cannot talk to C and D. So in this way we have divided the switch into two broadcast domains, two VLANs. And that's all well and good, but what if we need to grow the network? We see a 5-port switch here. What if we have many more devices that need to be connected? Well, we can of course buy a bigger switch, but that doesn't scale very well in the end. So it would be nice if we could buy another switch and connect it to the existing switch in such a way that multiple VLANs can traverse between both switches. And this connection between the switches, that's what a trunk is, as we will see in the next slide. So as you can see here, we have two switches. We again have the red VLAN 10, the green VLAN 20, but we also see the blue trunk that carries both of these VLANs between the switches. And the result of this configuration here would be that A and B can talk to E and F, C and D can talk to G, and that traffic will all traverse the trunk. Now the switches on both sides of the trunk need a mechanism to determine to which VLAN traffic belongs. And this all happens on layer 2 of the OSI model. The OSI model is beyond the scope of this tutorial, but on layer 2 we need to know that all the traffic is encapsulated in frames. And what we do, we use a protocol called 802.1q to tag the frames with the VLAN ID. And that way the switches on both sides of the trunk can distinguish between the VLANs. Now use cases for a trunk, of course, connect two switches together as we see here. But another use case might be that you have a VMware server, or maybe you use Hyper-V or Xen or what have you. And inside of the VMware server will be a virtual switch, a vSwitch, to which the virtual machines are connected, each in their respective VLAN. Between the vSwitch and the real switch, there will be a trunk. So that's another use case. Another use case could be a router on a stick, because we have many VLANs here, as you can see, or some VLANs. And what if we need to route traffic between the VLANs? We can of course connect the router with many ports to many VLANs, but we can also connect the router with one port to a trunk, and then configure the trunk to pass the VLANs that we need on the router, that we need the router to route between, and connect the router that way. And that will be a router on a stick, and that's another use case for a trunk. Now, as I said, the switches on both sides of the trunk, or the devices on both sides of the trunk, need to distinguish between the VLANs. So they need to know what VLAN a frame belongs to. And we do this with 802.1q, and that will tag a frame with the VLAN ID. And we can see here how that works. You can think of a frame as an envelope in which the data is put. And if you compare that to a real life envelope for you to send a letter to somebody, that envelope will have a destination address, it will have your sender address, but maybe if you send to a large company or a large organization, you could put a department number or a room number. And you can think of the tag in that way. So as you see here, we have our frame, we have our destination address, our sender address, and we have the tag with the 12-bit VLAN ID. 12-bit, 2 to the power of 12, this will give us 4096 values. We cannot use VLAN 0, so VLAN 1 through 4095 are the VLANs that we can play with on the trunk. So now we know what is a trunk, what is a VLAN, and let's get into the configuration. This is our lab for today. It's my home lab. It's organically grown over the years. There's no real logic behind it. I need to revise that someday. We only need the devices within this rectangle though, so it's nice and clear. We will configure the Mikrotik router here, the MR3, and we will turn what is now an access port into a trunk port. And on that trunk port we will add VLAN 10. Now the Cisco switch 5 is already configured, but I will show you how that was configured. And then in the end we will have VLAN 10 added to this trunk. And we will move the laptop to VLAN 10 to prove that we can communicate over VLAN 10 all the way to this server, which is also in VLAN 10. And if that connection works, we have done good. So that's our goal of today. Now to configure VLANs and trunks, there's multiple steps that we need to go through. So first you need to open Winbox. and we need to create the VLAN. And to do that, you can go to Bridge and click the plus character. So go to Bridge, click the plus, and then we add our VLAN. And I like to name them logically, so that the name tells me what it is. You can name it anything, but in this case I'm creating a bridge which will be used for VLAN 10, so I like to call it VLAN 10 bridge. So now we have created the VLAN itself. The next step will be to add ports to that bridge. And to do that, we again go to Bridge, then we go to Ports, we select the port that we want to move to the new VLAN, and in the drop-down box we will select the new VLAN. I also like to name my interfaces with logical names, so that I know what is connected to that port. And in this case my Ether 1 is connected to the switch, the Cisco switch, so I call it Ether 1 switch. Ether 5 is empty, leeg is Dutch, it means empty. So it's a nice candidate for our experiment. And later we will also move the Ether 2, where my dock is connected, to which my laptop again is connected. So now we have that port Ether 5 connected to our new VLAN, but nothing else is connected yet, so we cannot communicate to anything still. So let's now first build the trunk. And to do that, we need to select the interface that we would like to convert into a trunk. And to do that, we go to Interfaces. And then the interface that we want to configure, we need to select it. And that's actually hidden behind this drop-down menu. It's the Ether 1 interface that you saw on the previous slide. You select that interface, and then we select the drop-down box next to the plus sign to add a VLAN. We give it a nice logical name. In this case, it's VLAN 10. And I want to put it on the trunk Ether 1, so Ether 1 VLAN 10. We give it the VLAN ID, again 10, and we select the interface on which we would like to add this VLAN. Now, of course, we already selected the interface here when we clicked on it, so this is already pre-filled. But you can also, in this drop-down box, select another interface if you made a mistake and want to correct that. Then as a final step, this VLAN interface that we created, we need to add it to the bridge as well. So we go again to Bridge, go to Ports, and it's not here. There is no VLAN interface. So that's why we click on the plus sign, and then we select Ether 1 VLAN 10 interface that we created in the previous step, and we connect it to the VLAN 10 bridge that we created in the first step. And then we're done. The result will be, as you can see here, that we have multiple ports connected to the VLAN 10 bridge, in this case the Ether 5 and the virtual Ether 1 VLAN 10 interface. And now devices on port 5 can talk to other devices in VLAN 10 on the other side of Ether 1. What you can also see on this slide is VLAN 31. And as you might have seen in the previous slide, and I will also show it in the live demonstration, we did not create a virtual VLAN 31 interface. In fact, you can see it here as well. So we have our Ether 1 interface with the virtual VLAN 10 interface, but where is VLAN 31? It's not there. VLAN 31 is what Cisco calls the native VLAN. So on the Cisco switch, I tag all the traffic on the trunk with the VLAN IDs, except for traffic on VLAN 31. I don't tag that. It's untagged. And yeah, that will mean that all the traffic which is not tagged, which is entering Ether 1, will be delivered into this VLAN 31. So that's what Cisco like to call the native VLAN, and pretty much every other vendor just calls it untagged traffic. Now in the CLI, it looks like this. I did include a step 0 here to show you how I name my interfaces. So we have the default name of Ether 1 and Ether 5, and I gave them a more descriptive name, just like this. What you need to know from these commands here is that they all go on one line. The output you see here is from the export command. And in the export command, everything is put on multiple lines, but in reality, these are 2 lines that start with /interface and then all the way to Ether1 switch or Ether5 empty. It's all on 1 line. And as you can see here, we have the 4 steps that we also saw in Winbox. So we create the VLAN 10, the VLAN itself. We connect Ether5 to VLAN 10. We create the virtual VLAN 10 interface on the physical Ether1 switch interface. And as a final step, we also connect that virtual interface to the VLAN 10 bridge. And yeah, what do you think? What is easier or more intuitive? Would you prefer to use Winbox to do this configuration, or would you prefer to use the CLI? I prefer the CLI. In the beginning, it takes some getting used to, getting to learn the commands, but I think it's faster and more clear in the end. On the Cisco side, we also need to configure the VLAN and of course put the interfaces in the VLAN and configure the trunk. It's done like this. Here we have our step 1, the creation of the VLAN. And on Cisco, if you type VLAN 10, press enter, you're done. The VLAN is there, it's active. But you can also give it a logical name, which I always like to do. Then we go to our interface, and in this example it's Gig Ethernet 0/10, and we put it in VLAN 10 and we enable the interface. Steps 3 and 4 are more or less combined on a Cisco. Let's say for this example we want Gig Ethernet 01 to be a trunk. Then first we need to tell that interface how to encapsulate our data, because on some older Ciscos you can use 802.1q as we do here, but there's also an older protocol called ISL, which is no longer in use, but many Ciscos still support it. So we need to tell the switch which way to encapsulate the frames to do trunking. Then we enter trunking mode and we tell the switch, and this is actually our step 4, we tell the switch which VLANs to allow on the trunk. And then the little extra step that I talked about some slides ago, the native VLAN. So we will allow VLAN 10 and 31 on the trunk, but traffic on VLAN 31 will not actually be tagged. And that's how to configure the trunk on a Cisco. Now we will go into the live demonstration. Okay, so to configure the VLAN and the trunk using Winbox, we open Winbox. This is my lab router. And then we first create the bridge by going to bridge plus, and we give it a nice descriptive name. So now the VLAN is created and we need to add ports to it. And our next step was to go to an empty port and just double click that and add it to the bridge, like so. But this port can still not go anywhere because it doesn't have a way out of the switch yet. So we need to create that trunk that this tutorial is of course all about. So yeah, I just wanted to move it around like this. And on this Ether1 port where the switch is connected on the other side, we need to convert this to a trunk and we need to add VLAN 10 to it. So we go to the plus, we add a VLAN. Give it a descriptive name, give it the VLAN ID, and now I told you in the presentation that when you would click the Ether1 interface and then click the plus, this would already be pre-filled with the proper value. It's actually not the case. Might be something to do with the version that I'm running. I will look into that, but it's no big deal. We can just click this drop down box, select the interface that we need, and we're done. So now we have converted Ether1 into a trunk, which will also listen to frames tagged with VLAN 10, but it's not connected yet to our interface. So as you can see here, we have for VLAN 10 only Ether5 connected. So we need to add this virtual VLAN interface that we just created here. So we go plus, we select our VLAN 10 that we just created and we connect it to the VLAN 10 bridge. And now we're done. So as you can see here, we now have both Ether 5 and the virtual Ether 1 VLAN 10 ports connected to the VLAN 10 bridge. Now let's look at the CLI side. So our step 1 was to add the new VLAN. And then the next step was to add the empty Ether 5 port to the new VLAN. And that was one step in Winbox, where we double-clicked the Ether 5 interface and we added it to the VLAN 10 bridge. And that was all one step. We will see that it's not actually one step in the CLI, because it's an existing interface, we cannot add it again. I will demonstrate. So it complains here that the device is already added as a bridge port, but to a different VLAN. We can see that here. It's added to VLAN 31. So what we need to do, we need to remove it first. And we can remove it by simply removing interface number 6. Because the interfaces are numbered, as you can see on the left. So what we can do is, we can just say remove 6. Now it's gone, and now we can add it as an access port to our new VLAN 10 bridge, which you can see here. Then the following step is to create the virtual Ether 1 VLAN 10 interface and add it to the physical interface Ether 1, effectively making that a trunk. Give it a VLAN ID of 10. And then the final step is to connect this new virtual VLAN 10 interface to the bridge to make communication possible between devices connected to Ether 5 and devices on the other side of the trunk, which is basically the Cisco network in my lab. And as you can see here, the result is that we now have both Ether 5 and the virtual Ether 1 VLAN 10 interface connected to the VLAN 10 bridge. And now we're basically done. To prove that we have connectivity between devices on VLAN 10 on the Mikrotik and the rest of the network, I will move Ether 2 to VLAN 10, which is the port that my laptop is connected to. And I will then do a ping. First, of course, I will reconfigure my laptop with an IP address in VLAN 10, and then I will ping a device in VLAN 10 to prove that connectivity is there. Before we go into that, I would like to show you the Cisco side of things. So on switch 5, I have things already configured. I promised to do a live demonstration though. So I will show you first the configuration that I already have in place. And then on an unused interface, we will do the configuration again. So here's my VLAN 10. It's already pre-created. It has a descriptive name as well. And I think on Gig Ethernet 08 we have our trunk. Yeah. So here you see the configuration of the trunk. We have told it to use .1q. We enable trunk mode. We allow VLAN 10 and 31, and we do not tag the frames on VLAN 31 because it's the native VLAN. So let's do this configuration from scratch with a dummy VLAN and some unused ports. Let's create a new VLAN 110. Now we've created the VLAN, but let's give it a descriptive name. Maybe like so. And then we can use two unused interfaces, one to do an example with an access port and one to do an example with a trunk. Let's use Gig Ethernet 03 for the access port. And enable the interface. Now we go into Gig Ethernet 04. We make this our trunk. We allow two VLANs over this trunk, 10 and 31. And now we just need to tell it not to tag the frames on VLAN 31. And enable the interface. We didn't give it a description, so let's do that now. And that's it. So we now have our Gig Ethernet 03 as an access port in VLAN 10. And we have Gig Ethernet 04 as an example trunk port. So now we've seen both the configuration on the Mikrotik side and on the Cisco side. Let's now do the test by moving my laptop into VLAN 10 and see if we can do some pings. Okay, so the final step is to move Ether 2 to VLAN 10 and see if we have end-to-end connectivity to our test system. And the best way to do this actually is through Winbox. And why is that? As I demonstrated during the CLI part of the demonstration, removing a port from a VLAN and adding it to another VLAN on the CLI is two steps, where the first step is to remove it from the old VLAN. And after that step, I will have cut myself off and I will not be able to connect to the router and add this port to VLAN 10. So that will be the end of it. But if I do it in Winbox, these two steps are combined. So in this case, this is the better choice. So we just select Ether 2 and we connect it to VLAN 10. There we are. And now I will lose connectivity to Winbox. There we are. Because I'm cut off from VLAN 31 and I was connected to the router through VLAN 31. Now, let's see if we have connectivity on VLAN 10. I don't have DHCP running, so I need to give myself an IP address. Now by default this is a /16, but I have it configured as a /24, so we need to overrule that. It's our gateway. Let's just use Google's DNS for now. This should do it. We should be connected again. And let's test that. Let's first look at ipconfig to see what it all looks like. There we are. We also got an IPv6 address. And the AB416 prefix is actually located on VLAN 10. So that's another indication that connectivity is working. Let's prove it beyond a shadow of a doubt. Let's ping our default gateway. And that works. And let's ping the test server, because that was our goal. And that also works. Now if we go back to our slide, we have moved the laptop to VLAN 10, and then we pinged our default gateway, which is switch 2, and we pinged the test server, the .10, and we did that in VLAN 10. So we proved that end-to-end connectivity in VLAN 10 is working. So that means that this interface has been successfully configured into a trunk, and VLAN 10 is passing over that trunk. So that's our goal, and that concludes the live demonstration part of this tutorial. We have seen what is a VLAN, what is a trunk, when and why do I need a trunk, and then we've seen how to configure this in Winbox and on the CLI. And at the end we did a test to prove that we have established connectivity in the new VLAN 10. And yeah, please let me know, would you like to see the same configuration being done in an automation tool, maybe through Ansible? If that's something you think is interesting, let me know in the comments below, and maybe I can record a tutorial on that. If you have any questions or comments, feel free to reach out to me, and these are my contact details. And that's the conclusion of our tutorial. So thank you for watching, and I hope to see you again in another video.